Hey everybody. Okay, so I've divided up this lesson into three parts. The last part is for something for you to do. So here we go. So first thing we're going to do is talk about air pumps or bicycle pumps. And this thing right here is the bicycle pump. Well, so is this too. But the thing that we need to know is that this is the downstroke and this is the upstroke. Okay, so we're going to focus on the downstroke first. So the first thing we need to do is identify the parts. This here is the edge of the tube of the pump. And this right here, I'm going to color it in, there's three names for it. I'm not sure why I put all three names in there, but it's called the flange, the malleable seal, or the bushing. I don't know why I used all three names. I made this note with help, and that's the three names I was given for it. Anyways, what we're basically doing is, as I say, we're going in a downstroke. So this malleable seal is moving down, and as it's moving down, it's compressing the air. And when it compresses the air, it causes a region of higher pressure. And when we say high pressure, we don't know exactly how high it is. We don't have a barometer. But what we do know is that it's higher than the air on the other side of the bushing. Okay? So as we go down, the bushing is being forced up against the edges of the tube because of the area of high pressure. Because we know the area of high pressure wants to get to the area of low pressure. But it's kind of closing the door in front of itself, so it's not able to do it. So the bushing is sealed, it's pushing down. The further down you go, the further compressed the air gets, the more high pressure air you get. Okay? That's on the downstroke. Now on the upstroke, again we have our malleable seal, our flange, our bushing, and we're pulling it upwards. And as we're pulling it upwards, we're creating an area of low pressure because we're taking that previous area that was condensed gas, and we're increasing the volume. We're not decreasing it like we were in the downstroke. We're increasing the volume that the air is occupying. So because we're increasing the volume, the air pressure becomes lower. And when I say low, I don't know how low. I just know it's low compared to the air out here, which would be equivalent to the air pressure outside in the world around us. So then again, you go back to the downstroke and you push the malleable seal down, and that reduces the volume of that the air is occupying, or that the gas is occupying, which gives us more high pressure. And then as the pressure is released and you bring the malleable seal up, it expands the area, it expands the volume that the gas occupies, and therefore lowers the pressure. So I'm going to post these all these handouts online, so you can get them from there. You don't have to make sure you copy everything down and read it quickly here. So that's the air pump. Next, we're going to get into Okay, secondly, we're going to get into the tire. So this is the tire, and specifically what we're concerned with in the tire is the tire valve. And the tire valve is this thing right here, this sort of eye-shaped thing. I call it the eye valve. That's not really what it's called. I have no idea what it's really called. But as it is kind of in the shape of an eye, a capital I call it the eye valve. So basically what we need to do is we need to understand the position that the valve is in. Right now the valve is open, and there's little notches right here and right here in the eye valve that are holes that allow gas to come in or out depending on wherever the high or the low pressure is. So if the gas is a higher pressure out here, then the gas, and it's a lower pressure in here, the gas is going to move in through the hole in the eye valve and into the tire. And as that tire gets inflated with air, the more compressed air we press into it, the higher the pressure of the gas in the air becomes. And again, it's higher compared to out here where it's lower. And as the gas's pressure is higher in the tire, it's going to try and get out again. But as it does so, it takes this eye valve and pushes it up against the edge of the tire. So it's kind of like the flange where it closes the door in front of itself. So the gas can't escape. So that's how the tire stays inflated. And it stays inflated because there's higher pressure inside the tire than there is outside the tire. Okay, and then once again, when if you need to fill the tire up with more air, there's going to be a higher pressure out here, which means this will be lower pressure, and the higher pressure is going to push the eye valve down, and it's going to go back into the tire and fill the tire until once again the higher pressure is in the tire and it's lower pressure out here. Okay, so this is where we kind of put the two diagrams together. We have the, this is the downstroke, and the bottom here is the upstroke. Okay, so when we say downstroke, it's because we're pushing the seal, we're pushing it down. We're compressing the air inside the tube, because we're reducing the volume that it occupies. Okay? On the upstroke, we are taking our malleable seal and we are moving it up. So we're actually increasing the area that the gas occupies. And the gas is in here. And we're increasing the area that the gas occupies, which causes it to come to a lower pressure. Now, because we're making areas of high pressure inside the tube, or creating an area of high pressure, it's pushing the eye valve down. And as we know, the gas will go into the tire because the tire is of lower pressure than it is outside it. And so we pump more air in. And as the more air we pump in, this becomes a high and this becomes low. Whoops. And it becomes low because, again, we're expanding the area that the gas occupies. On the upstroke, whoops, I forgot an E there. On the upstroke, the high pressure is in the tire, and it's pushing the eye valve up, and it's closing the door in front of itself so it can't escape. And as the air in here has already just been pumped into the tire, and now we are using an upstroke to expand the area that the gas occupies, this now becomes an area of lower pressure. Okay, so what I want you to do with this diagram is, I want you to, just give me a second here. No, that's not the one I'm looking for. There it is. What I want you to do with this diagram here is you can see these lines. Let me get my pen back working. Here, you can see these lines. There's one here, there's one here, there's one here, 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 and here. And you can see that there's some circles, and what you need to do is fill in a letter in those circles with either an L or an H, depending on whether or not you're creating an area of higher pressure or lower pressure. And you're basically describing the movement of the gas into the tire and then the movement of the gas as it tries to come out of the tire. And what I want you to do here is I want you to just give a brief description of what's happening in that area, and submit it to me, email me your answers, and we'll take it up next day, of course, assuming that a high percentage of you actually hand it in. So thank you very much, and we'll see you next time.